Okay guys, we are now going to be finishing up our lesson that we started yesterday about limiting and excess reagents with more of a focus on what's happening with the excess reagents today. Okay, so we're going to start today by determining how many moles of the excess reagent are consumed. Another way that we kind of talk about this is how much of the reagent is left over. And really all that is figuring out how many moles of the excess agent were required, which is how many were consumed, and then subtracting the amount that's consumed from the original amount to get the amount that is left. So of course we start by writing and balancing a chemical equation, figuring out the moles of the limiting reagent, use the mole ratio to figure out how many moles of the excess reagent are required or needed. That is the amount of the excess reagent that's used. And then if it's asking for the leftover reagent, again, we just subtract that from the amount of the reagent we started with. Okay, so let's go through this example together, and then you guys can try this one. Is that how I want to do it? Sorry, let me think about this. I think we're actually going to do this one together, and then I'll get you guys to try the other one. Okay, so the first question that we did on slide 9 yesterday was this one, where we had the lead nitrate reacting with the sodium sulfate to make the lead sulfate and sodium nitrate. And we figured out that our lead nitrate was the limiting reagent. So when we're trying to figure out how much of our excess is used, all we're going to do is look at whatever our excess was, which was our sodium sulfate, and then we have to set up a mole ratio where we're solving for the amount of sodium sulfate needed. Now, I already did that yesterday when I was trying to figure out which one was in excess and which one was limiting. However, some of you may have put the X here and solved for the amount of lead nitrate, in which case you would just have to redo the mole ratio with the X in this position where the excess reagent is. But I already know the amount of sodium sulfate my excess reagent needed, and that is the amount that was consumed. So the amount that's consumed is just the amount that you get in the mole ratio when you solve for your excess reagent. Now, if I wanted to know how much was left over, I would just take the amount I started with, the 0.0845, and subtract the amount that I need, 0.0453. And if it wanted that in grams, you would just use moles equals mass over molar mass to convert it to grams. Okay? The second reaction that we did yesterday was this one here. And sorry, let me just focus this a little bit better. There we go. Where we had potassium and fluorine reacting in a synthesis reaction. And in this case, we figured out that potassium is limiting. And we did that by solving for the amount of potassium needed. Now, in this case, I am going to have to go back to this mole ratio here. This will kind of be our step 4. Actually, step 4 was identifying that fluorine is in excess, just like we identified the potassium is limiting. Step 5 will be going back to this mole ratio between our two reagents, which is still a 2-to-1 ratio, but this time we have to solve for the amount of excess reagent, which means I put the X here and plug in the amount of potassium on the other side and cross multiply. and we get 0.1795 divided by 2, 0.0898-ish moles. That is the amount of fluorine needed, which is the same as the amount consumed. Now, you will sometimes be asked to identify how many grams of the excess reagent is left over. And if that was the case, I would just go moles equals mass over molar mass. I would plug in my moles and my molar mass of fluorine, which is 38. And I would get 3.41 grams of fluorine that was used or consumed, since that was this amount. And then all I would do is say, okay, I started off with 5 grams of fluorine. If I used 3.41, then I just subtract that from 5, and I get 1.59-ish grams of fluorine that are left over. Okay. So that many grams consumed, this many grams left of our excess reagent. Okay, what I would like you guys to do now is try, without looking at all of the answers here, try to solve that question, figure out how much of the excess reagent is consumed and how much is left over in grams, and then check your answer at the bottom there. By the way, guys, for those of you that didn't keep your work from yesterday, this is how we solved it yesterday. We found out that magnesium chloride is limiting, and therefore that the aluminum sulfide is in excess. So you can just go from here to calculate the rest of your answer. And again, you can check your answers right on that slide. Okay, the next thing we're going to be going over is something called reasonable excess. Essentially, it's saying if you want to make sure that you use up all of one type of reactant or that you make a certain amount of product, how much of the excess reagent should you reasonably use? And the scientific community describes the amount you should reasonably use as 10% more than what you need, just to make sure that if you accidentally lose some or it gets stuck on a stir rod or on the sides of a beaker, you're still not going to run out. So anytime you're asked for the reasonable amount of excess or the reasonable amount of a reactant, always figure out the amount you need and then add an extra 10%. So again, in order to do that, we start with a balanced chemical equation. You figure out how many moles of the excess reagent you need by using the mole ratio. And then you turn that into a mass, calculate what 10% of that mass would be, and then add that 10% mass. So let's run through, you guys can look over this example on your own. We will do the first one here together, and then you guys can try the other two on your own. Okay, so for the reasonable excess, we are reacting calcium sulfide with sodium phosphate. So that would be a double displacement reaction. That would look like that. And then in order to make sure that this is balanced, we're going to put a 3 in front of the sodium phosphate. Actually, one sec, let me work through this on my own. Okay, sorry, this should be a 2 here. That's what was throwing me off. So yeah, that is a 3, not a 3 there. That is a 3 here, a 3 there, and a 2 here in order to be balanced. So we have 3 calcium on each side, 3 sulfur on each side, 2 times 3 is 6 sodium on each side, and then 2 PO4 on each side. We are told that we have 9 grams of our sodium phosphate. It wants to know how many grams of our calcium sulfide we should use reasonably. So the first thing that I'm going to do is write out my molar mass for these guys, since I am definitely going to need that. So calcium is 40 plus 32 for sulfur is 72 for calcium sulfide. And then sodium phosphate is 23 times 3 for the sodium plus 30.97 for the phosphate plus 4 times 16 for the oxygen is a molar mass of 163.97. So all of that is step 1. Step 2, I'm going to do moles equals mass over molar mass for the reagents that I was given the mass of. So in this case, 0.0549-ish moles of our sodium phosphate. Then I'm going to set up a mole ratio between my calcium sulfide and sodium phosphate, which is a 3:2 ratio. I will plug in the moles of my sodium phosphate and solve for the moles of calcium sulfide. And you should get roughly 0.0823 moles of calcium sulfide. Now that's how many moles I need, which is not quite what I am going to use reasonably. But my next step, step 4, is to convert that into grams using moles equals mass over molar mass. Now using the molar mass of my calcium sulfide, since this is calcium sulfide. So of course I just multiply by the 72 and get 5.93 as my mass of calcium sulfide needed. My next step, step 5, is to figure out what 10% of that is. So I just do 0.1, which is 10% as a decimal, times 53.93, and you will get 0.593. And then the last step is to just take the amount that I need, the 5.93, add the extra 10%, and get roughly 6.52 grams that I should reasonably use. Okay, so please try number 2 and 3 on your own now. Okay, for the second question, we have calcium reacting with iron iodide to make iron and calcium iodide. In this case, it gives us the grams of the product that it wants us to produce. And it's asking for the grams of calcium that need to be used. So I'm going to find the molar mass of both of those. Then I start by doing moles equals mass over molar mass for the thing I have the mass of. That gives me 0.0716 moles of the iron. Then I set up a mole ratio between the calcium and the iron, which is a 3:2 ratio. which should give you 0.1074 moles of the calcium that would be used up. I'm then going to convert that moles of calcium to mass by using moles equals mass over molar mass and get 4.297 grams of calcium used. I then multiply it by 0.1 to figure out what 10% of that would be, which is 0.4297. And then I add that to the 4.297 to get roughly 4.7 grams. That should be reasonably used. Okay, and for the last one, we have some ethane or C2H6 reacting with oxygen. It's a combustion reaction, so we're going to make carbon dioxide and water. And then we balance it with a 2, 7, 4, and 6. I was given the grams of my ethane and asked for the amount of oxygen that I should use. So I'm going to start by finding the molar mass of both of those. And then I can find the moles of, again, the thing I'm given the grams of. So I'll do moles equals mass over molar mass and get 0.76 repeating moles of the C2H6. Then I'll set up a mole ratio between that and the oxygen, which is 2 to 7. You should get 2.683 repeating moles of oxygen that are used. I then convert that into grams by doing moles equals mass over molar mass. You should get 85.86 repeating grams of oxygen used. I multiply that by 0.1 to figure out what 10% of it would be, and then add that 10% to the 85.86 repeating, and you should get roughly 94.45 grams of oxygen that it would be reasonable to use. All right. Okay, so that is it for this lesson. If you have any questions, of course, feel free to ask me. But from now on, as we move forward, anytime you are asked for the mass of a product, just remember you always have to figure out what your limiting reagent is first if you're not told. Okay.